Hello, our prob stats class. Sorry about that. We are on 13.3, which is our last section. You'll need stat disk and your calculator this time. And we're going to do a Wilkinson sign test. So it's a little bit different. Stat disk does most of the work for us. And let's get going. Okay, when you're on here, we're going to do a Wilkinson sign test. And it's used for matched pairs. Some of those will be from two sets of data, and some of them will create. We're going to use a non-parametric, which means it only truly looks at the signs. We're going to do a matched pair, which is the property that the matched pairs have differences. So we have matched pairs, we have two sets of data, and a median that's equal to 0. The other thing we're going to test is a single population. And we're going to take that single population, compare it to a median equal to some claimed value. So we're going to do a median equal to some claimed value, meaning we are going to create a matched pair here. Is what's happening. And we're going to check against that value. Now, when you're going through here, we have to calculate T, our test statistic, and our critical values. Now, when we have a T equals the smaller of the two numbers. So we're looking at the total sum. So like how many positive numbers and how many negative numbers. So the sum of the positive ranks and the absolute value of the sum of the negative ranks. So who has a bigger number? Of the non-zero differences B. So we're going to calculate those, and that's what we're looking at. And we'll show you that here in a little bit. It's also on stat disk. Now, the requirements has to be a simple random sample. The populations and differences has a distribution that's approximately symmetrical. It means that the left half of the histogram is roughly a mirror of its right. All right, it does not have to be bell-shaped. Just has to be a rough mirror. If it's less than 30, the test statistic is T. If it's greater than 30, we're going to use stat disk. Unfortunately, this time, stat disk does not calculate the p-values. Okay, we cannot find this. Stat disk does not have this capability, so we'll only be using the test statistic and the critical value. So we'll be using these two, both found using stat disk. All right, when we go through, we're going to look at age of actresses and actors. So now we go here. I got my actresses and my actors here. The first thing we're going to calculate is our D, or our differences. So we take and we add and we subtract these to figure out what our differences are. Now, the rank of D is literally you take the absolute value from highest to smallest. So like 2 is the smallest, so that's 1, then 11, and then 12, and then 13, or not 13. Let's look, 16, and you just keep going until you have them all ranked. Now you do the signs of those. So this one was negative, positive, and that's what you're looking at. So when we look here, we have 2 positives and 2 positives here, and the rest are negative. If it's 0, it does not count. All right, stat disk will do this for us, but we kind of have to understand, oh, by the way, the 7.5, which I think you should look at here. The reason this is 7.5 here is this is 7 and 8, but they are both identical. So since they're both identical, when you rank them, you add them and divide by 2 and give them the exact same number. So that's why those are 7.5 instead of 7. I'm hoping some of you noticed. So in stat disk, I want you to put in the first 2 values for me, and we need to do that. So now you're going to go to stat disk and enter those 2 columns. So pause and get that done. All right, now that you've got those 2 columns entered, the third column I wanted to show you how you could do without using the calculator for when it gets longer. So you're going to go here, you're going to go to your data, and we want to do a sample transformation. We did this, but it was a long time ago. What we're going to do is we're going to take our actresses, we are going to subtract, and we're going to use our column value, our actor. And we're going to place those in our third column, or our transformation, and it gives us our plus and our minuses, and that's what we're going to use for our histogram. So now when you have that done, you go to Data, Histogram, and let's just plot it as is to show you how bad this is. Oops, I forgot to select. Our transform data is what we're looking at. And if you look, it's kind of a mirror, but it's not very good. So let's see if we can change this a little bit. Let's go to class width and let's do 10. And let's say our starting point, what was our smallest? -35. And plot that. All right, again, not very good, but it still is pretty much a mirror. If you look, the middle section, the two to the left are the tallest, and the ones directly out of that are the shortest. So sort of a mirror, definitely not a bell, but absolutely a mirror. So we will accept this as if it is working. So now let's get back to here. So you've done stat dist, you've entered in your numbers, you've calculated your differences. We've checked our requirements, and if we look, we know by the design it was a random sample, so that one checks. And when we look at our differences, we have a mirror image on the right or the left, so both work and we get to count. And just in case you're confused, you're looking right here. So these two are both tall, these two are both short, a very rough mirror, but yet a mirror, and we're taking it. Hypothesis, the null is that there is no difference. So your null hypothesis, no difference. And your alternative hypothesis is there is a difference. Now, test statistic and critical value using stat disk. I know by hand our stat disk should have been t is 2 because we only had 2 positive. But our calculation, 2 positive by hand, our calculation on stat disk is going to give us 3. So let's get back to stat disk. When you go here, you're going to go to analysis. Now we've got our Wilkinson's test on the bottom, and we have a matched pair. We are going to look at the actress and the actor. We are going to use a 0.05 significance level and hit evaluate. Now down here, there's not enough for it to do a lot, but it will give us a little bit. We have the test statistic, which is 3, and our critical value, which is 6. Okay, back to your notes. All right, so now we've got 3 for the T, and the critical T is 6. In the signed test, Wilkinson signed test, if the critical value, the test statistic is less than the critical value, so you're here, we should reject the null if it's less than or equal to the critical value. So in other words, if our test statistic is less than or equal to the critical value, we reject the null. Since 3 is less than 6, we reject the null. Since we're rejecting the null, which is there is no difference, we are concluding there is a difference in age between the actors and the actresses. Okay, it's your turn. I know I typed this wrong. This should be between repair shops, so please fix that. Type this information into your stat disk and let's see what you get. Okay, after you typed everything in and you did your transformation, you looked at your basic histogram. And when you looked at your histogram, the transformed data is not good, right? So if you look here, and I don't care what you use to define your class widths, it still did not turn out very pretty. So basically here, we actually have not met the requirements and we should stop. But just for practice, we're going to continue because this is definitely not a mirror image. It's because they're all positive is what's going on here. So once you have that done, now we need to go to your analysis and we're going to go to your Wilkinson's test and we want to do a matched pair. Now when you look at your matched pair, we're going to compare shop 1 to shop 2 with a 0.05 significance level and evaluate. Okay, we got a test statistic of 0 and a critical value of 1. So now let's get back to our notes. So our null was no difference and our alternative there is a difference. So hopefully you've got that all written out. So you should have null, no difference, alternative there is a difference. You can compare to the 0 to the 1 it's less than, so reject the null. So you should have concluded there's sufficient evidence to conclude that there is a difference between the two repair shops. And that's all you can say. You cannot say repair shop 1 is greater than repair shop 2. That is not what the Wilkinson's test tells you. It just tells you that there is a difference. Do we know that by logic? Absolutely. But we cannot say that from our test. All right, next is a single sign. So now we're going to have one and we're going to compare it against one value that we want to see is true or false. And we're going to use temperature. So we're looking at a single population this time, and we're going to create our matched pair. So we're going to test a claim that a single population has some claimed value of the median. And we're going to rank test to do this. So we're going to say it's yes or no, just positive or negative. Now let's go through here. We're going to use body temperatures. So our data set 3. We're going to use the 106 temperatures that are on 12 a.m. on day 2. And we're going to test them against 98.6 with a 0.05 significance level. All right, in order to do this, we have to download data set 3. So let's get to our stat disk. All right, let's go. Let's clear our data here. And we want our data set 3 with body temperatures. Now, if you look at day 2, 12 a.m., we have a blank data. So someone forgot to take data is what this means. Whenever you have blank data in a assigned test, you insert the median. And since we're comparing against 98.6, 98.6 goes in that spot. And then you check the rest to make sure that none of them are missing, which none of them are. Now, we got to add another column here because I have to compare them all against 98.6. So let's go to add a column, and we're going to add one column here. And we have to put in 98.6 to all of these values. And all the way down, this has to be done. I'm sure there's a better way. I just don't know what it is. So now I'm going to copy these. And we're going to continue to put these in. So after you have those all set in, so I'm hoping you're doing this right now. You're not just watching me, right? So you get your 98.6 put in for every value because we're going to compare these dates for the 12 a.m. data times 298.6 to see if there's a difference or not a difference is what we're looking for. So it's 98.6, the correct temperature. And we all compare against that, so I'm hoping it is. Kind of doubting it, but you never know, right? Your doctors won't lie to you. Okay, we've got to be getting close here, I'm thinking. All right, now that we have all of our data in, we have to also check our histogram. So we got to make sure that our data values at 12 a.m. are good. We want to look at this one, and we want to plot this. Oh, that's a beautiful histogram. Look at that. It's pretty much a mirror. I know that the ones on the right are a little higher, but they're not terrible. So now let's go to analysis, Wilkinson's test, matched pairs, and we're going to compare our 12 a.m. to our 98.6s that we put in there. Okay, now we're going to get a lot of data, which is what we need. We look at our test statistic, which is negative 5.38, and our critical value, we need the negative, which is negative 1.95 or 96. So back to our notes. So when we go through here, we've looked at our data. It's a rough mirror, not a good one, but a rough, and it is a random sample. So both requirements were met, which is what we like. Random sample, it's kind of rough, but it's a do. Approximately symmetrical, we're going to take it. Okay, we've typed in our matched pairs. For our Wilkinson's test, we got a negative 5.38, and our statistic is a negative 1.96. When we compare, the negative 5.3 is absolutely less than the negative 1.956, which means we reject the null. And since we are rejecting the null, we are claiming that there is a difference between the body temperatures. All right. Any questions on that? I hope you did well. Now, I want to talk about your homework a little bit here because I've changed it a little bit because of actually your capabilities of stat disk. So instead of 5 or 6 and 13, we are not going to do 13, and you're going to do 5 and 6. So cross off 13, and I want you to do both of these. So do number 5 and 6. Do not do 13. And I think that should cover it for you. All right, so you want to look at, I also want you to do, no, you should be good there. All right, if you have questions, let me know. Make sure you're using your stat disk and have a great day.